In 11.1 Part B, we're going to look at how to simplify radical expressions using the quotient property of square roots. How are radical expressions used in space exploration? A spacecraft leaving Earth must have velocity of at least 11.2 kilometers per second, which is about 25,000 miles per hour, to enter orbit. This velocity is called escape velocity. The escape velocity of an object is given by the radical expression square root of 2gm over r, where g is the gravitational constant, m is the mass of the planet or star, and r is the radius of the planet or star. Once values are substituted for the variables, the formula can be simplified. For any numbers a and b where a is greater than or equal to 0 and b is greater than 0, the square root of the quotient a over b is equal to the quotient of each square root. Somewhere, someone decided that we could not leave radicals in the denominator, so we're going to have to use that rationalizing square root bit. We're going to start off with the same way we started off with the products, and rewrite the square root of 12 as square root of 4 times square root of 3. And I know the square root of 4 is 2. Now to rationalize the denominator, I'm going to take that times square root of 5 times square root of 5. Anything divided by itself is 1, and when we multiply by 1, we don't change the value of the number, we just change its appearance, just like when we got common denominators. Square root of 3 times square root of 5 is square root of 15. Square root of 5 times square root of 5 is square root of 25, which is 5. Same thing here, I can rewrite square root of 27 as square root of 9 times square root of 3, and I know that the square root of 9 is 3, but I'm still not supposed to leave that radical in the denominator, so I'm going to take that times square root of 3 over square root of 3. So I get square root of 33y, and our European friends put a little hook on the end of that so we can see where it ends. And square root of 3 times square root of 3 is square root of 9, which is 3, times the 3 that we already have is 9. Square root of 8 I can rewrite as 4 times 2, and I know that the square root of 4 is 2. And I'm not supposed to leave that radical in the denominator, so I need to rationalize the denominator. Square root of 2 times square root of 3 is square root of 6, and square root of 2 times square root of 2 is square root of 4, which is 2 times the 2 that's already there is 4. A fraction containing radicals is in simplest form if no prime factors appear under the radical sign with an exponent greater than 1, and if no radicals are left in the denominator. Rationalizing the denominator of a radical expression is a method used to eliminate radicals from the denominator of a fraction. Now, if we end up with a sum or a difference in the denominator, we need another trick called conjugates. So if we had, say, 3 plus square root of 2, we'd want to use the conjugate, which is 3 minus the square root of 2. Conjugates are useful when simplifying radical expressions because if they're an example, if p, q, and r and s are rational numbers, then the product is always a rational number with no radicals. Look at the pattern. When we use the difference of squares factoring technique, that middle term is going to drop out. So to simplify this, I need to multiply by the conjugate of the denominator. So instead of 5 minus square root of 2, I'm going to multiply by 5 plus square root of 2 over 5 plus square root of 2, because anything divided by itself, even a sum, equals 1, and 1 times anything's itself, so we haven't changed the value of the number. Now, the numerator is no problem. I'm just going to have 15 plus 3 square root of 2. The denominator might be more interesting. So we get 25 plus 5 square root of 2, wait for it, minus 5 square root of 2. Opposites are going to cancel out. And positive times the negative is negative. Square root of 4, which we all know is 2. So my final answer is going to be 15 plus 3 square root of 2 over 25 minus 2 is 23. That was interesting enough. I thought we might look at another one of those. So the conjugate of this denominator is going to be 3 plus square root of 5, or 3 plus square root of 5. And as we multiply, 4 times 3 is 12, plus 4 square root of 5 over 3 times 3 is 9. Plus 3 square root of 5, here it comes. Minus 3 square root of 5, and then minus square root of 25, which is 5. Opposites cancel out, so we end up with 12 plus 4 square root of 5 over 9 minus 5 is 4. Okay, happens to be this time that both of those are divisible by 4. So 12 divided by 4 is 3, plus 4 divided by 4 is 1. We don't normally write the 1 times square root of 5, so that would be our final answer. A radical expression is in simplest form when the following 3 conditions have been met. No radicand have perfect square factors other than 1. No radicand contain fractions, and no radicals appear in the denominator of a fraction.